At Big Bear Lake in the San Bernardino National Forest, there are a number of endangered and threatened species that the National Forest Service is working to protect. The bald eagle is one of those species and is going to be the focus of our analysis today. We want to model the habitat of the bald eagle. And to do this, we're going to look at 3 variables that we know are related to bald eagle nesting. And we're going to overlay those variables. The first variable that we want to look at is a land cover variable. We know that bald eagles prefer to live in areas that are not too sparsely covered by forest and not too densely covered by forest. Anywhere between 40 and 70% tree cover is ideal. We also know that bald eagles prefer to live in areas that are close to large bodies of water. I've run a 500-meter buffer, 1,000-meter buffer, and 1,500-meter buffer, and we can use the results of this analysis in our overlay. Lastly, we know that bald eagles avoid urban areas, major roads, and any other sort of human disturbance. So we can include that in our overlay analysis as well. But we also know that bald eagles don't make decisions based on discrete variables and polygons like the ones we see in our map. In order to more realistically model the habitat of the bald eagle, we're going to take advantage of some of the enhancements to spatial analysis in ArcGIS 10, specifically some of the new fuzzy logic tools. I've created a model which is going to take each of those 3 variables and reclassify them using the new fuzzy membership tool. The graphs in my model represent the methodology that we're using to reclassify those variables, but we'll take a closer look at that in just a minute. Next, those reclassified continuous surfaces are overlaid using the fuzzy overlay tools. The end result is a suitability map of bald eagle habitats. So let's take a look at those reclassified variables. The first variable that we want to look at is the distance from Big Bear Lake. The graph shows us that the closer we are to Big Bear Lake, the higher the suitability. And as we get farther away from the water, the suitability decreases. Next, we can look at the human disturbance variable. The graph shows that there's a linear relationship and that when we're very close to urban areas and that distance is small, our suitability is low. And as our distance increases from those human disturbance areas, the suitability increases. Last, we want to look at the tree cover variable. Rather than saying that anything between 40 and 70% tree cover is suitable and everything else is unsuitable, we're able to use the fuzzy membership tools to more realistically model how tree cover is related to bald eagle habitats. We can see in the graph that those mid-range percentages are all considered suitable. And as we go to higher percentages and lower percentages of tree cover, our suitability decreases. So we're able to use these continuous surfaces and the fuzzy membership tools to more realistically model how these variables are related to bald eagle habitats. Now I want to run my model, which is going to take each of those 3 variables and overlay them using the fuzzy overlay analysis tools. The end product is going to be a suitability map, which shows us the areas that are most likely to have bald eagle nesting. In green, we can see the areas that are most suitable for bald eagle nesting, and in red, the areas that are the least suitable. We're able to use these new fuzzy logic tools to more realistically model complex phenomena that are not adequately modeled using discrete variables, and that's really powerful. Now I want to move on to show you some of the enhancements in network analysis in ArcGIS 10. Just 60 miles west of Big Bear Lake is the Angeles National Forest, where just 6 months ago, the station fire burned 250 square miles of forest. Not only did the fire itself pose a major threat to life and property, not only did the fire itself pose a major threat to life and property, the burned mountainsides now pose a greatly increased risk of mudslides and flooding in the rainy winter months. We're especially concerned with those areas where mudslide and flooding could lead to a loss of life or property. and lead to evacuations, like this area just north of Pasadena. What we want to do is plan for evacuations in the potential mudslide areas. We know where the populations are that will need to evacuate, and we have 36 potential locations for evacuation centers. What we want to do is choose the best locations for our evacuation centers so that we can minimize the travel time for all of our evacuees. In order to do this, we're going to use a new tool called location allocation. Our location allocation analysis takes as inputs those evacuating populations and our 36 potential locations for evacuation centers. I'm going to set some of the parameters for our analysis. For the problem type, we'll choose minimize impedance. This lets us minimize the travel time for all of the evacuees. We also want to choose 5 facilities. That means that out of those 36 potential locations, we're going to choose the 5 evacuation centers that will minimize the travel time for everyone. So I can accept those parameters and run the analysis. The results are going to be the 5 best locations for our evacuation centers. We can also use location allocation and other enhancements to network analysis to help us include some real-world challenges that we'll face in the event of a situation such as a mudslide. In this example, we've gotten word that there's some flooding that's going to be slowing down the evacuees as they make their way to safety in the event of an evacuation. In order to include that information in our analysis, we're going to rerun our location allocation analysis, this time with some barriers. So in order to include those flooded areas, all I have to do is draw some polygons on my map. The ability to use polygons as barriers in network analysis is another enhancement in ArcGIS 10. Now, these polygons don't actually represent barriers to travel. They really just represent an increased travel time through those areas. So I want to include an attribute that represents that increased travel time. Now, we want to rerun the analysis, but this time we want to include a 15-minute cutoff. What that means is that not only are we able to minimize the travel time for all of the evacuees, we're able to make sure that nobody has to drive more than 15 minutes. This allows us to ensure that we're providing these services equally to all of the citizens in the area. Now, the evacuees are being directed to either side of the flooded area based on those new parameters that we included in our analysis. So we were able to use location allocation and the enhancements to network analysis in ArcGIS 10 to help us choose the best locations for our evacuation centers and to ensure that we're providing these services equally and responsibly to all of the citizens. And today I've shown only 2 of many enhancements to spatial analysis that are coming in ArcGIS 10.